Hello, in today's session we are going to cover frequency interleaving and I am the presenter Suvarna Kadam. Now let us start about the frequency interleaving, and before starting the frequency interleaving we'll revise some of the concepts which we have seen in the previous sessions. So we know that horizontal scanning frequency is nothing but the when it comes to the horizontal scanning frequency, we know that how many lines are scanned per unit time. So here how many lines you are scanning in 1 second. So how many lines are there in our system per second? 625 lines. How many frames are there? 25 frames, and that's why 15625 hertz is nothing but the horizontal scanning frequency. If I want to convert this into the kilohertz, it will become 15.625 kilohertz. Now as we are not going for the progressive scanning, this 25 frames are divided into two fields. One field will be the odd field and other field will be the even field. So you're having 25 odd fields and a 25 even fields. So total fields in 1 second will be 50 fields, and that's why our field frequency or the vertical scanning frequency is a 50 hertz. ठीक है, horizontal scanning frequency is a 15.625 kilohertz and a vertical scanning frequency is a 50 hertz. This means that 15625 lines get scanned in 1 second and 50 fields get scanned in 1 second. ठीक है, so number of lines are 15625 and number of fields are 50 fields. So what happened when, now this is all about the luminance signal. ठीक है, I want to transmit my chrominance signal or color signal. I'll call it as a chrominance, or you can say this is nothing but the color signal. ठीक है, मुझे I want to transmit my chrominance along with my luminance. ठीक है, but what happens whenever you're talking about the transmission of your luminance signal along with the chrominance signal, you will see you are having a horizontal scanning frequency here, and the harmonics appears of this horizontal scanning frequency for twice of fh, thrice of fh, and so on. And what kind of power will be there associated with, now you can see the amplitude versus this frequency which is in the megahertz, and we know that this particular frequency exists up to 5 megahertz because my video bandwidth is 5 megahertz. So if it has been determined that the energy contents of signal is contained in the individual energy bundles which occurs at the harmonics of the line frequency. Sometimes your horizontal or your horizontal frequency is also called as a line frequency, as it is the number of lines in 1 second. So you are having 15.625, 31.250, that is twice fh is this one. The component of each bundle being separated by a multiplier of the field frequency, that is 50, 100, 150 and so on. Sorry, 50, 100 like that, okay, and 150, 200 and so on. Now, the shape of each energy bundle shows a peak at exact harmonics of the horizontal scanning frequency. ठीक है, यहाँ पे आपका जो पीक है सो एग्जैक्टली एट 15625 पे, twice fh 30.215 पे है, like that. ठीक है, so the energy contents progressively decrease with increase in the order of harmonics and is a very small beyond 3.5 megahertz from the picture carrier. So if you'll see this is nothing but the energy, and this is decreasing in manner, and it will be very small beyond 3.5 megahertz. So in this particular, what you are doing to avoid the picture crosstalk, to avoid the crosstalk between your luminance and your chrominance signal, the frequency of the subcarrier is chosen on the high side of the channel bandwidth, whereas close to the 5 megahertz and above 3.5 megahertz. So it is 567 times one half of the line frequency in the PAL system. So 567 you can see by half. So I can say this is a 567 divided by 2, which comes 283.5. ठीक है, so if you are calculating this one, that is 2 into 283 plus 1, because you're not going to put it in like अगर आपका ये 283 FH है और अगर आपका ये 284 FH है, तो आप इसके बीच में यू आर गोइंग टू इंटरलीव योर कलर सब कैरियर. ठीक है, सो दैट्स वाई 2 into 283 plus 1 into 15625 by half, because in between of this one. Okay, so 4.43 megahertz. Otherwise you can calculate this in other way also, 283.5 and you into 15625, which comes in a similar manner. So 283.5, if you do it, 283.5 into 15625, which comes 4.43. So that way you can do, other way you can do the calculation, 283.5 into 15625, which comes same as this one. So this is for our system, which is 625 line system. But if you talk about the NTSC, or you can say the American television system, your bandwidth is smaller than our bandwidth. Okay, so our bandwidth is up to 5 megahertz, their bandwidth is up to 4 megahertz. Okay, that's why the subcarrier employed is 455 times one half of the line frequency. So you can say 445 ka half. I'll do it in my way. So ठीक है, 445 by 2 into one half of the लाइन फ्रीक्वेंसी. उनका लाइन फ्रीक्वेंसी अलग है क्योंकि उनके 525 लाइन्स है और उनके हाउ मेनी फ्रेम्स फील्ड्स है, 30 फील्ड्स है. ठीक है, सो इफ यू कैलकुलेट इन दिस वे ऑल्सो विल गेट दैट पर्टिकुलर थिंग्स. ठीक है, बट in other way if you are doing in this way will also be okay. ठीक है, 2 into 227 plus 1, 15750 by 2 and approximately equal to 3.58 megahertz. Now if you see here, you are having this Y signal. ठीक है, and it is existing up to 5 megahertz. 5.5 megahertz you are interleaving your sound carrier, and then if you can see here above 3.5 your energy is decreasing, and in between of two horizontal harmonics of horizontal frequency you have interleaved your color subcarrier. ठीक है, and it is interleaved exactly at a 4.43 megahertz. So you can say your chrominance information falls between the Y signal harmonic, and this concept is called as a frequency interleaving. So you can see here this is your 563 fH by 2, 282 fH. So this is your luminance, which is to a lower power level, and this is nothing but the you have putted your you can say 4.43 ka color subcarrier, and its harmonic exists in between of your luminance signal. So no effect or no interference happens between luminance and chrominance. So here this concept is called as a frequency interleaving. And if you talk about the PAL system, it is 4.43 megahertz, and for NTSC your color subcarrier will be 3.58 megahertz. So we will stop here. Thank you.